Okay, so here we go. Number 14. A basketball player, it's a lot like number 13. A basketball player is shooting free throws. The function diddle-a-diddle-a-diddle-a-da gives the height of the basketball in feet after X seconds. How high does the basketball get? How long is the basketball in the air? So, I'm going to take a real quick peek at this and hopefully get off to a good start so where your brain can kind of handle this information. So here's my x-axis, here's my y-axis. The question is, the basketball player is shooting free throws. What is the original height? Well, think about this. X is 0 means the ball has not been in the air for any time. So if I put a 0 in there, it's 0. If I put a 0 in there, it's 0. The y-intercept would be 4. So 1, 2, 3, 4. The original height is 4. Just like the original height of this was 45. This is a sneaky little 4 given to us kind of hidden cryptically in this little equation. But now I kind of get a generic drawing of the ball. Gives the height of the basketball in feet. How high does the basketball get? How long is the basketball in the air? Assuming it's a swish, it's going to look something like that. So, again, we got to find the vertex, and we have to find this. But this is now seconds. In other words, how long was the ball in the air? So, we're going to go at it the same way. I'm going to put this in vertex form to find this x and this y. So, we get y equals negative 2x squared plus 8x plus 4. Even number, even number, even number. Very tempting to divide by negative 2 or try to deal with this as a trinomial and factor this. Don't do it. We need this to be a complete, we need to complete the square. So kick that to the curb. We get y equals, and I'm going to put brackets around these two. This has to be a 1. So I'm going to take a negative 2 out. X squared minus 4x plus space plus 4 plus space. Take half of negative 4 is negative 2. Square it is 4, but that's 4 times negative 2, which is negative 8, so I got to add 8 here. Now I'm going to clean this up, and then I get x minus 2 squared plus 12. What's my vertex? 2, 12. What does that tell me? My height is 12 feet. So 12 feet is my height. That's how high the ball gets. Now how long was the ball in the air? We got to find x. Now remember, there is no negative time. So when we solve this, we're going to go to the original. We know that when the ball hits the ground, y is 0, or the height is 0, and that tells us what to do. So we're going to go 0 is negative 2x squared plus 8x plus 4. Now you could say let a be negative 2, b be 8, c be 4. Plug it into the quadratic formula and be good. I'm going to take one more step of simplifying this just so my numbers are smaller. So 0 equals x squared minus 4x minus 2. Now I take a quick peek at this and I can see that that's not factorable. So my a has to be 1, b is negative 4, c is negative 2. And I'm going to plug that into that formula right up there. So I'm going to take the opposite of whatever b is. So b is negative 4, so that's positive 4, plus or minus the square root of b squared, 16 minus 4 times a times c, all over 2a, which is 2. Now this is 8. So 16 plus 8 is 24, so I get the square root of 24. And so what I'm going to do is take my calculator, give me a second, and I'm going to find the square root of 24, so let's do that. I could break that down into 2 square root of 6, but that's not really going to help me because I got to find out the exact time. So that's we'll call it 4.9, we'll round a little bit. So negative 4 plus or minus 4.9 all over 2. Now again, we're looking for the positive answer. So what's negative 4 plus 4.9? That'd be 0.9 over 2. So I'm going to go 0.9 divided by 2. And that doesn't make sense. Give me a second here. All right, so some of you observant ones, you noticed, I didn't notice right away, but I could tell by my answer there's just not enough time for that ball to be in the air. So that positive 4 I turned into a negative. Why? Who knows? So I get 4 plus 4.9 is 8.9 divided by 2. And let me show my work there. So 4 plus 4.9 is 8.9 divided by 2. Let's figure that out. 8.9 divided by 2. So we get 4.45 seconds. Now, I know that 4 minus 4.9 is negative 0.9 over 2. We don't worry about the negative because there is no negative time. And that's it. So, on to number 15. All right, number 15 is a pretty simple problem. Couple ways to do this. First of all, bada boom, bada bing, do the right thing. And so we get x is plus or minus. Now notice the square root of 144 is 12. But if we take the I out, which Ron taught us to do that, now we're going to have that, which is plus or minus 12i. All right, so that's the best way to do that one. Number 16, as you can see, divisible by 2. You don't have to, but it's the best move on that first move. And I end up getting this. Now, you can always shove things in to the quadratic formula, but if you don't need to, don't. In this case, you don't need to because that factors into x minus 4 and, whoopsie, x plus 4, x plus 3. And so my answers are negative 4 or negative 3. You'll get the same thing if you plug it in here. Maybe you want to do that and practice it. But number 17, notice how this one was set equal to 0. We're going to do the same thing with this guy because that's just what makes it work. So I'm going to get started like so. Give me a second. And so now we set this equal to 0, put it in descending order. So x squared minus 13x plus 12 is 0. And this one's strangely factorable. X minus 12, x minus 1. And that means x is 12 or 1. Remember, if you don't notice this is factorable, you can always use the quadratic formula. So number 18, very similar. We're going to set it equal to 0, so we're going to add 13. Add 13, so 5x squared plus 3x plus 13. Now maybe this is factorable, I doubt it, but because I haven't shown you an example of quadratic formula, let's just use it. So negative b would be negative 3 plus or minus the square root of b squared minus 4 times a times c all over 2a, which is 10. I'm going to do some math here. 4 times 5 is 20. 20 times this would be 260, I think. So this gets kind of weird, but this would be the square root of 9 minus 20, 200, yep, 260, which would be the square root of a negative 251. So if I take the I out of this thing, I'd get I square root of 251, but there's a plus or minus in front of it. So this thing boils down to negative 3 plus or minus I square root of 251 all over 10. And that ain't going anywhere. So that's done. Okay. And the last one for this video, write the product, which is a little hint to multiply. So they're just saying multiply that out. So 3 times 2 is 6. We're just foiling. 3 times I is 3i. Inside would be negative 10i. And then be careful with this. Negative 5i times positive I would be negative 5i squared. These are like terms. So I'm going to clean those up. Negative 7i. This right over here, I didn't mean to make that look like a plus sign. But I squared is a negative 1, so it's really like negative 5 times negative 1, which is 5. And 5 times 6 is, or 5 plus 6 is 11. So I get 11 minus 7i. And that's it.